Okay, in this video, I'm going to do problems 4 and 5. Problem 4 says you're given this graph. It says, what is the concentration of cobalt if the solution absorbs 0.74? I plugged it in. I said corresponds to 0.013 molar. And then part B says calculate the moles in the 50 milliliter solution. And I did that, and I got 6.5 times 10 to the negative fourth moles. And then it asks you to find what's the percent of mass if you had 0.63 grams. Well, I found I should show you this. I found 0.0383 grams of cobalt, and that divided by 0.63 grams of cobalt gives 6.08%, or 6.1% to the two significant digits there. Okay, on problem number 5, you're given a reaction there. And quad A says, predict the sign of the entropy change for the reaction. I said entropy is positive since 1 mole of gas is product versus none as a reactant. So in other words, there's more disorder with that. And of course, that makes entropy as being positive. And then it says to, in part B, use the information in the table to calculate the standard enthalpy change. And I should probably write this down for you. I had 2 times negative 286. 1 times 90, 3 times 101, 4 times 207, and of course 3 times 0 be 0. So negative 572, 90, negative 303. Okay, because this is minus here, products minus reactants. Negative and negative, so plus 828, of course that's 0, and I get a positive 43 kilojoules per mole. And then part C says to find delta G. Okay, delta G is delta H minus T delta S. And so we can see then that 43, and that is negative 298 times delta S. And then the other part of that would be 43 minus 368 delta S. And so I said that 95 has a greater chance of having a negative value if the entropy change is very large. Because again, you see this is a much higher value being at 95 degrees, and that's what they're asked to find. And then, what was the rest of that question asking you? A student runs a reaction, suggests a method they can isolate the silver nitrate. Well, I said the nitrogen gas is going to bubble out, and I just evaporate the water. And then you'd have silver nitrate would remain. And I think that would be a valid method there. Let's go ahead. I think I'd be okay to go ahead and jump to problem number 4. That way, or excuse me, problem number 5. That was 5. Problem number 6. Let me spit it out here. Problem 6. Get the right page here. It says, calculate the heat energy needed to raise the temperature of the sand by 180 degrees. And I'm just going to show you this here. So you get 1650 cubic equals MC delta T, 1650, 0.81 joules per gram degree Celsius, 180 degrees. Convert joules to kilojoules, you get 241 kilojoules. And then part B says calculate the number of moles of butane that was used in the experiment. You subtracted the amount of butane that was used, which you get 7.06 grams. Convert that to moles at 58.12. You get 0.12 moles, 1 moles of butane. And then it said in letter C of that one, it says here's the combustion, has a negative 2659 kilojoules per mole. Calculate how much heat is produced by the burning of butane. Well, you've got 0.121 moles of butane. We're math here, you can see okay. And then you get 81 was lost to the, you get 322 kilojoules of energy was produced. And then part D of that says student claims some heat energy produced by the combustion was lost to the air surrounding the system. Do your answer support that? Well, yes, we had 322, and we only needed the 241 was obtained, so that lost 81 kilojoules of energy, and therefore that must be lost to the environment. Okay, in problem number 7, And you've already seen my answers there as I was flopping that back and forth. You're given some reaction. And so I had Y is, I said X is neutral, so strong acid, strong base. Y, neutral salt plus strong acid, therefore it's going to be acidic. And Z, weak acid plus the basic salt, that's going to be in a buffer. So I said Y less than Z less than X. And then part B asks us, does the pH of Y increase, decrease, or remain the same when 100 milliliters of water is added? I said it's going to increase since the hydronium ion decreases and use pH equals negative log, therefore the pH would increase. And then last question says, you're adding 0.1 molar sodium hydroxide solution Y and 0.01 molar of sodium hydroxide solution Z. So the volume of solution does not change. The pH of solution Y changes much more than solution Z. Explain your observation. Well, Z again is a buffer because again it was, as we mentioned above, a weak acid and a salt, a base of that. So therefore it's going to be absorbed small amounts of acids and bases without the pH changing. And Y is not a buffer. That's why I got a more significant change of that. So those are the problems. Again, if you have specific questions, please email me and I'll try to answer those. Thanks. Bye.